Hello and welcome to the TauNet update for October. You're here with me, Fola, and without further ado, let's get right into the development team. Over to you, Karim.
Thank you, Fola, and welcome everyone to the October update for the Tau development team. Let me start with Andrei as usual. Andrei added live P2P stack and the gossip protocol to the Tau testnet node and taking testnet from a single node to a distributed blockchain, which is a major improvement step. He also added 6 Tau protocols and finalized the sync procedure between nodes so they can go from bootstrapping to handshake to headers to blocks to states and finally to the gossip protocol. He also started work on a JSON-based network service with persistence, read optimized API, and simplified operation via a config file to help peers quickly bootstrap onto the network. The network service also offered very clean interfaces for wallets and chain explorers. Lucca this month worked on integrating the normalization algorithm we call anti-prenexing algorithm. And it's a new normalization algorithm that will replace the old one. And he's currently working on finishing up the integration of that algorithm into the rest of the Tau code base. He also added the ability to manipulate BDD paths for formulas in Boolean normal form. He also added variable assignment extraction optimization as well as pre-processing step as a pre-processing step before the solver. He also added the integration of new BDD variable order for formulas tailored towards quantifier elimination procedures. And after all of that, he also managed to sneak in several improvements and implementations to the splitters and to the interpreter itself. David this month focused his efforts on the type resolver after having implemented bit vectors the month before that. He's been enhancing the type system so we can deal with a new type called bit vectors, but also with additional types and additional Boolean algebras in the future. So the new type system is meant to deal with the variable bit size vector, which is kind of a parameterized type. And it will also allow us to remove the special syntax that Ohad doesn't like at all with the underscore equal. So right now he's wrapping up that integration of the new type resolver into the code base. Tomasz, on his side, he did help David on the type resolver, and but before that, he worked on caching of free variables with Lucca, and he fixed some bugs that had to do with static member initializations. And finally, he took some time to explore and experiment with a library called FTX UI, which is a terminal UI library that will greatly improve the Tau command line in the near future. Umar, as usual, was working on the Tau parser library. In particular, he improved the handling of the write recursive productions that sometimes occur as a result of some eBNF rules. He optimized data handling through duplication in the tree. He also fixed issues with cyclic forced nodes. And together, all these improvements have really strengthened the Tau parser library, both in terms of stability and performance. That's it for the development team this month. Back to you, Fola.
Amazing. Thank you so much, Karim. I'll pass it over to you now, David, for your update this month.
Thank you, Fola, and hi everyone. This month I have refactored the type resolver in order to have a general type system that will allow us to solve several issues and also deal with future needed extensions. For example, dealing with types as tables, extracts, and so on. The main short-term objectives were to deal with variable bit vector bit size in a proper way after the merge of with the Tau tree branch, we need to fix several issues, and also simplify the bit vector grammar to remove the special syntax used in bit vectors to disambiguate in certain expressions. The first point has been mostly solved. I will deal with the second one next. In any case, the previous type resolver was limited to a general BA types, but we need to keep track of extra information as, for example, the bit vector width or the signature of the other types. Broadly speaking, the new type solver is designed in such a way that could be easily adapted to the typing of new BAAs, the ones corresponding to tables, structures, whatever. It essentially relies in a scoped union find algorithm as the previously one used for computing bit vector widths, and consider not only types in the sense of formulas, tau formulas, SBF, or bit vectors, but also subtypes, for example, bit vector widths, table schemes, or structs definitions. Right now, I'm wrapping the integration of the new type resolver in Tau. Mostly is right now dealing with bit vector sizes. And that's all for my month. Thank you all for listening. Back to you, Fuller.
Thank you, David. That was great. I'll pass it over to Lucca for his update this month.
Thank you, Folo. Hello, everyone. Thank you for joining. So this month, I have mostly worked on tasks related to integrating the new normalization algorithm called the anti-prenex algorithm into our code base. Also, some tasks on the anti-prenex algorithm itself were left, which I attacked. So one of the challenges in integrating this algorithm into the code base was that we moved to a new normal form. Previously, the formulas after normalization were in disjunctive normal form, which made formula manipulation very easy. And now with the new BDD-based approach for normalization, we also end up with a BDD, which we do not want to convert to DNF due to potential size issues arising in this transformation. Therefore, capabilities to rewrite formulas in Boole normal form was needed. After this procedure was in place, the integration was smooth. And yeah, on top of the now available optimizations which come with the anti-prenex algorithm, also, for example, that equalities are not immediately simplified to the equal zero normalized form, but are kept in place. This enables to smartly extract variable assignments as a pre-processing step from the solver, which lightens the burden to the solver algorithm, and also makes the results from the solver, due to how the algorithm must work due to theory, the results are smaller, basically, or not in need for further, or not in as much need to further normalization. Let's put it that way. Then, as an advancement to the anti-prenex algorithm itself, I implemented a new BDD variable order for formulas, which is tailored toward quantifier elimination procedures. Because when you want to eliminate quantifiers or basically the formula below the quantifier should be such that atomic formulas, which are equations in our language, that contain those the variable that's currently quantified, they should be placed more up in the BDD level, because this makes the elimination process more efficient in terms of the BDD size. So figuring out and implementing this order was also one of the tasks. And while I did all the integration into the rest of the code base, I also took the time to revisit some open tasks in the splitter and the interpreter algorithm. And I was able to finish up some of the ones. So yeah, that's been my month. Thank you very much, and I'll pass it back to Vola.
Thank you very much, Lucca. That was enjoyable. I'll pass it over to Andrei for his update this month.
Hello everyone. This month I achieved a major milestone with Tau net development, and that implementing a complete peer-to-peer networking. Now we moved from a single node prototype to a fully decentralized blockchain network where peers can communicate with each other, synchronize headers and blocks, and propagate transactions. The system is based on a robust libp2p networking stack, and nodes now bootstrap from known peers and persist peer connections even after restart. I've implemented a separate networking service that works in asynchronous way alongside the blockchain and maintain protocols, connections, and everything related activities. So I've implemented also 6 protocols. That's a handshake, that's synchronizing block headers, that's obviously blocks for serving full-size blocks, and that's state for synchronizing state, and gossip for gossip connections. So I've integrated a gossip subscription service. Now nodes subscribe to 2 major topics, that blocks and transactions, and blocks is used for announcing new blocks, and transactions obviously for propagating transactions across subscribers. The impact, of course, is significant, so the decentralization is now fully functional. What left is, while Tau language is catching up with Tau blockchain development, I will implement a Kademlia DHT-based peer discovery and routing that would allow us to get not only peer discovery and routing, but also decentralized storage, because, for example, this system works everywhere, like IPFS and Ethereum also based on this approach. So see you next month. Thank you for your support and enthusiasm. Bye.
Thank you very much, Andrei. That was great. And now I will pass it to Ohad to wrap it up.
Yes, I continue working on better algorithms to support tables, which seem very necessary. During this work, many new insights and properties about Boolean algebra were discovered, which will be very helpful along the way. But the problem that I try to solve in better support for tables is very elusive, and I will need more work on it. It's still not finished.
All right, fantastic, Ohad. Thank you so much. Thank you to all of you for joining and watching the video. I appreciate likes and follows on our socials. That is Tau_net on Twitter. That is TauNet on Telegram. And that's TauNet Agrs on Reddit. We'll see you on our socials. Thank you.